Okay, in this video we are going to do some multiple choice calculator review for the AP Calculus AB and BC exams. So if you're taking BC, you have to know everything from AB, which is why this would be relevant to you. It's problem set number 7. There is a playlist of all the other problem sets. There's also a link to the problems in the description below. The problems that I do are not from actual AP exams, but they're all based on problems from AP exams. Because you can't release a lot of those exams, ask your teacher. They should have those available for you to at least look at. But let's get started. So I'm going to be using the calculator. I got a lot going on. Hopefully it looks smooth to you guys. We'll find out. So first question. A particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals -3 over the natural log of 2 plus t plus 5. If the position of the particle is x equals 5 when t equals 3, what is the position of the particle when t equals 8? Okay, so to me, I'm looking for this thing at t equals 8. I also know that x is 5 when t is equal to 3. So I'm going to use the fundamental theorem, just kind of like rearranged, right? I know like fundamental theorem says x of 8 minus x of 3 is equal to the integral from 3 to 8 of v of t dt. So rearranging that, I get x of 3 plus, and then it would be the integral from 3 to 8 of v of t dt. All right, and now we're going to do the calculator part. So let's see. What is relevant here? All right, so I'm going to press menu, and I'm going to add a calculator page. And I'm going to define this function, right? So v of t and then colon equals, which is control and template. And then control division to get a fraction, -3, press tab. Natural log has its own button. So I'm going to try to press the buttons as I do this. It's much faster for me to just type, but t plus 2 plus 5. Okay, so that's v of t. And then what I want to do is I want to do what the problem says, right? So I'm trying to do x of 3, which is 5. So I want to do 5 plus, and then I want the integral from 3 to 8. So there's a shortcut for the integral template, which my students tell me is a lot faster on the handheld. I have my doubts, but I want to do 3 to 8. I'm pressing tab to move between things, and then I'm going to press var because I stored it of t dt, press enter, I get 2.854, so approximately 2.854, put a box around it. Let's move on to the next question. The first derivative of the function f is defined by f prime equals the quantity 5x cubed minus x squared times cosine of radical x squared plus 1, where x is between -1.6 and 1.6. We want to know on what intervals is the graph concave down. Okay, so I know concave down means second derivative has to be less than 0. So what I'm going to do is use a calculator. This one's like 100% calculator. I'm going to insert a new problem, right? So right now it's 1.1. Press doc. Option 4 is insert, and option 1 is problem. And I will insert, I'm going to insert a graph page. Okay, and you can see at the top now it's 2.1. I'm in problem number 2 on the problem set and problem number 2 on the calculator page. It's a really good idea to try to maintain that. It's kind of hard. I should say on the calculator section of the AP multiple choice, there are 15 questions, but like 7 of them maybe will require a calculator. It's unusual to have a ton of them. And also, I think they make the assumption that you're pretty bad or slow at using your calculator because they give you a lot of time for that section. So get good at your calculator, and it just gives you like a lot of bonus time. All right, what am I going to do? I am given f prime, right? So I'm looking for where f double prime is positive, so I need to find the derivative of the thing they gave me. So shift minus will give me the derivative. And now I'm going to carefully enter this function, 5x cubed minus x squared cosine. You can use the trig button to get cosine, which I probably should have done. Square root, So that's control something, control x squared, and then x squared plus 1. So a really good idea, because a lot of the functions are just insane outside of the region you're told to look in. I'm going to change the window. So menu 4, 1, go negative 1.6 to 1.6 before I even graph. So I'll never know how insane this thing might have been outside of that window, which is good. I need to find where this thing is greater than 0, so I can visually, less than 0, because we're looking for concave down. I can see it, so what I'm going to do is press tab, going to graph 0, and then do menu 8.1, so menu 8.1.4 if you have a CX2, menu 8.1.3 if you have a CX or below, menu 8.1.4, and what this does is it gets all of the intersection points at the same time, which is super useful, except they're all on top of each other. So what I'm going to do is press escape to get rid of the tool, and then kind of grab and drag. So I do not like using the touchpad, but sometimes you kind of have no choice. So you can see there's this little tiny space here, and maybe I can make it clearer. I'm going to go menu, option 4, Windows settings. I don't need to see all this Y stuff. I'm going to go like negative, negative 0.5 to 1. You can see right here we're actually negative. So I want to go from negative 0.915 to 0. No, I don't. Man, I keep trying to do greater than 0. I want to go negative 1.6 to negative 0.915, and then 0 to 0.133, and then 0.944 to 1.6. So that's a lot of regions. So I want to write those down. All right, so let's do that. So therefore, negative 1.6 to negative 0.915, 0 to 0.133, and 0.944 to 1.6. So I was looking for where the second derivative was less than 0. I was given the first derivative. That's kind of a trick they like to use a lot, if you want to call it a trick. All right, let's move on to the next problem. Well, why should I cover it up? All right, let's move on. Number 3, a tap. While a tap is turned on, the depth of water in a tank increases at a rate modeled by R of t equals 2 plus t squared cosine of pi t squared over 150. That's a crazy function. Where t is the time in minutes since the tap was turned on, and R of t is measured in gallons per minute. So R of t is a rate, right? So it's like the derivative of something. How much did the depth of the water in the tank increase from t equals 0 to t equals 5? All right, so what do we got here? We got R of t is definitely a rate. You always want to keep track of that. What are the units? Well, gallons per minute, right? So gallons per minute, if I integrate over time, which is in minutes, will give me just total gallons. So I'm looking for how much did the depth of the water increase. So I am looking, and we're going from 0 to 5, I am looking for the integral from 0 to 5 of R of t dt. That's what I'm looking for. If I can integrate the rate, which is in gallons per minute, over time, which is in minutes, that'll give me gallons. So this one's pretty straightforward. Let's see. I'm going to do doc for new problem. I'm going to do this totally on the calculator page. So I'm going to define the function R of t colon equals 2 plus t squared cosine of pi is in the pi key times t squared over 150. Okay, and then I want to do the integral, so that's shift and plus from 0 to 5 of, press var to get your list of functions, which is just R of t and dt, and you probably want to press control enter just in case this is like insane. 49.254 and then gallons. So 49.254 gallons. Okay, so you can like pause this at any time, you can rewind, keep that in mind if I'm going a little fast, or if I'm going slow, you can skip ahead, who knows. All right, let's look at the next problem. Oh, gallons, yeah. I'm getting murdered here. Okay, here we go. Okay, The acceleration of a particle moving along the x-axis is given by a of t, which is equal to 1 plus the quantity 3 minus t, cosine of 3t over 2 minus pi for 0 to 5. At what value of t is the particle's velocity increasing most rapidly? All right, so let's see. So if I had like a graph of velocity, so let's just make some graph of velocity. If I had a graph of velocity, it might look like this. So velocity is increasing anywhere. So velocity is increasing anywhere you can visually see, anywhere this graph is increasing. So like here and here. So if velocity is increasing, that would mean acceleration is greater than 0. So if acceleration is greater than 0, velocity is increasing. I'm looking for where this thing is increasing most rapidly. So what I'm actually looking for in this problem, I am looking for when a of t has an absolute maximum. That's what this problem is asking me for. All right, so I'm going to go through the process of figuring that out. When does a of t have an absolute maximum? All right, so that's our goal. Back to the calculator, because I'm not going to be able to do it without it. So doc for new problem. And okay, so I guess I'm gonna add a graph, and I'm gonna type in this function. So 1 plus quantity 3 minus. Remember, if you're graphing a function, you have to use x as your variable. So even though it's 3 minus t is given, I have to use x. Cosine of 3x over 2 minus, and then pi. So you know you tried to use the wrong variable if it asks you if you want to create a slider. That's like, it's telling you definitely did that wrong. So I'm going to change my window. So menu 4, 1, 0 to 5. All right, so this is the graph of acceleration. I want to know when this has an absolute maximum. So it's like either here or here. So what I'm going to do is I'm going to graph the derivative of this. So derivative, so shift and then minus, shortcut, and then derivative of, I already typed it in, right? So I'm gonna use f1 of x. All right, so I'm going to find this point and this point. So I'm gonna add, press tab, 0, and then I want menu 8, 1, option 4 if you have a CX2, option menu 8, 1, 3 if you have a CX. So this is the first graph, and then I wanted F2, so this. And now what I'm going to do, so press escape to get out of the tool, I'm going to store, so this point right here, 3.071, that's a minimum, right? Because this thing's going from negative to positive, so it's a minimum of the function it's the derivative of. So I'm going to store these two. So you arrow over it, and you press control menu, which I actually can't do on the emulator. So control menu, choose store. I'm going to store this as A, and I'm going to store this as B. Now what I'll do is just add a calculator page, so doc 4 and then option 3. And I know that if you get lost with what you've stored, right, I have 3 functions, so if I can just recall it, right? F1 of x. F1 of x is my acceleration. So what I want to do is F1 of 0. So I'm doing the candidates test. F1 of 0. I want to do F1 of A, F1 of B, and F1 of 5. Which, okay, let's do control enter. All right, so the biggest value I got was this, which means that is the value, so B. So that's my answer. 4.472 is when the velocity is increasing most rapidly. So it's increasing and it has the biggest value. All right, so A of t has absolute max. I don't really know why I'm going through the trouble of writing out like good final explanation. I guess like you should always practice as if this might be an open-ended question. All right, we get that. Next question. All right, let R be the region in the first quadrant bounded by the graph of 3 sine squared of pi x over 3 and 1/3 x cubed. The region R is the base of a solid. All right, so this is like known cross sections. For the solid, each cross section perpendicular to the x-axis, so that's a big deal, is an isosceles right triangle with its hypotenuse in the region R. What is the volume? All right, so I'm gonna go through I actually have this memorized. I memorized like all the cross sections so I could just like blow through them. But so that's like square, rectangle of arbitrary height, isosceles right triangle, equilateral triangle, semicircles. Those are like the default ones. All right, let's see. So here's our thing perpendicular to the x-axis. I'm going to call that h because it's the hypotenuse. And then it's going to be h of x is top take away bottom, right? So for this particular thing, the top is the trig thing. So h of x is going to be 3 sine squared of pi x over 3, and then minus 1/3 x cubed. Okay, so that's h of x. And then I know that in general, what I'm trying to do here is for known cross sections, you always want to just integrate from start to stop area of a cross section. So that's my goal. Now I need to kind of like work out what the area of a cross section is, right? So it's an isosceles right triangle. So the hypotenuse is h of x. So it's like side, side, side root 2. So hypotenuse is side root 2, which means each side is the hypotenuse divided by root 2. So it's this, but also this. And that means that the area is 1/2 base times height because it's just triangle. So base and height are the same, so that's 1/2 h of x over root 2, quantity squared. All right, and then I definitely just, at this point, I need a calculator, right? So let's go to the calculator, do doc for add a problem, calculator, I'm gonna define h of x is 3 sine of pi times x over 3, and then square the sine function, minus 1/3 x cubed. Okay, that's what I was looking for. I need to know where these things are equal, which is equivalent to just saying like where does h of x equal 0, right? I need to find out this intersection point right here. Well, and this one, but I'm pretty sure that's 0. So what I'm going to do is just do it, right? So let's say solve. I'm going to use solve. Menu 3, enter, h of x equals 0 for x. So this will find where the two graphs intersect each other. It gives me those two values. If you don't like that, you could insert a graph page, graph h of x, graph 0, do menu 8, 1, 4, and here. The advantage this has is that it's really easy to store this value, which is why I actually do this kind of a fair amount, even though solve is much more convenient. All right, so I have that value. So I now know that like a is equal to 0 and b is equal to 1.936. So I'm gonna write those down. And now what I want to do is the integral, right? So let's evaluate it. So I want to do shift plus to get the integral, 0 to b, because I stored it as b, so I might as well use it. 1/2 quantity. I stored this as h of x over square root of 2. I mean, I guess calculator problems do just take longer. X, press enter, 0.949, I guess. So let's write that down. So integral 0 to 1.936 of a of x. And then that we found was approximately 0.949. All right, let's do another one. The graph of y equals e to the tangent of radical x minus 3 crosses the x-axis at one point in the interval from 0 to 1 what is the slope of the graph at this time? All right, let's insert a new problem. This one seems like it'll be quick. I don't know, none of them are quick. I'm gonna do this all on, well, not all on the graph page, but I'm gonna start on the graph page. I'm first going to change my window to 0 to 1. Always a good idea, so I should actually do the things I say are a good idea. All right, let's graph this. So it's e to the tangent of the square root of x and get all the way down minus 3. Okay, I can see it definitely does cross only once. Press tab, 0. So I can find this point. I'm going to do menu 8, 1, 4. And there, so I get that. I'm going to store this. So shift, control, store. I'm just going to store it as A. Okay, so let me first say, like, what was I doing there? I was trying to find when y is equal to 0. And when y is equal to 0, I found that the x-coordinate is 0.693. And now the problem is saying, what is the slope of the graph at this point? So that's saying find dy dx when x is 0.693. I have all the values stored. So let's actually find it. So you can see I get 0.3977. I'm going to show you two ways to do this. We're on the graph page. I could do menu 6. Option 6 is dy dx. Choose a graph. So click on this one. Choose a point. See how it says like point on? When you get to the actual point, it doesn't say point on, it says point. So I'm going to click that. And then as soon as I click that, a number pops up and is right on top of the other. So I get 0.3977, which is what I got. Alternatively, I just don't trust that. I don't really know why. I'm going to insert a calculator page, and I'm going to do shift minus, which is the shortcut, x, press var, f1 of x, and then such that, so control equals, such that x equals a, which is what I stored that intersection as, and I get it this way. It doesn't matter how you do it, you'll get the same answer either way, pretty clearly. For whatever reason, I just don't trust the things on the graph. It's like they're too easy, and it feels wrong. So I don't like to do that. All right, new problem. More water. Water is pumped out of a tank at a rate of, I'm definitely going to get this. I got this wrong. Water is pumped out of a tank at the rate of R of t equals 45 quantity 1 minus blah, 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 gallons per minute, where t is the number of minutes since the pump is turned on. If the tank contained 1,000 gallons of water when the pump was turned on, how much water to the nearest gallon is in the tank after 14 minutes? Okay, so I definitely did this wrong when I wrote this out ahead of time. So what I'm going to do is write out a solution now that is correct. So here's the wrong solution. Ready? I'm just going to blow through it. There were 1,000, blah, blah, blah. I added, so I didn't really read the question. So this is a problem. This, I got 1,291. That can't be right? Because water is pumped out of the tank. So what I'm going to do, if I could find my stylus here, mostly because I'm doing this all in one take and I'm not re-recording 23 minutes. That's crazy. So instead of this, what I'm going to do, you can kind of watch as I do this. Well, you won't be able to see all the details, but what I'm going to do is I'm going to copy some stuff here. Copy. I'm going to paste it. It's like a little behind the scenes editing type thing. So I'm done with that. Now what I'm going to do is mess that up. Okay, I want to, I'm just going to erase some stuff. Well, I don't want to erase that. Go back here. I want to, nope. I want to erase that. Okay, that's what I want to do. Okay, so this is my goal. I want to do this. I'm going to say this is totally, get out of there, totally wrong. Okay, now what I'll do is use the calculator to actually find this answer. So it's going to be approximately something. This is what happens. Sometimes you do a problem. You know, it's funny, like I did the problems and then I redid the problems to check them, but never once did I actually read the problem. So I'm going to insert a calculator page because I think I can do this all on the calculator page. So I want to do, let that be a lesson to you. Reread the problem, right, and see what's happening. I should have gotten less if water's being pumped out. All right, so R of t is 45, the quantity, 1 minus e to the negative 0.1 t gallons per minute. Okay, and then I'm going to do 1,000 minus the integral, so that's shift plus, from 0 to 14 of r of t dt. So what I didn't do that kind of messed me up is I didn't check to see if r of t was giving me a positive or a negative value. It's giving me a positive value, which means if I like add, I'm just putting more stuff in. I had to take it out. It's kind of a nuanced thing, right? So you gotta make sure that you're actually doing what the problem asks, obviously. All right, so what are we doing? To the nearest gallon, so 709 gallons. Let's put a box around that, but let's put it in a different color because we messed up. There we go. All right, that's definitely what we wanted. Okay, so back to hopefully our regularly scheduled programming here. All right, new problem, having totally mastered that one. All right, if f prime, I thought that was gonna be a fast problem when we were doing it. All right, so if f prime is 3/5 x cubed minus the square root of x to the 4th plus 5 minus 4x plus 1, then f has a local maximum at x equals. Okay, so I know how to do this, right? So a local maximum, I'm given f prime, which again is a little weird. I just need f prime to change from positive to negative. So this question's strange because all I need to do is graph this function. So let's do it. Doc 4, new problem. I'm going to graph because I just need to see where it changes. So 3/5 x cubed minus square root of x to the 4th plus 5 minus 4x plus 1. Okay, so there's only one point where we're changing from positive to negative. It's right there. So what I'm going to do, I don't usually do this, I'm going to do menu 6 and just find the 0. There's only one that makes it work. So I'm going to click here, scroll across, click there. That's the 0 where this thing changes from positive to negative, which means that that's our local maximum. So therefore, approximately negative 0.314. All right, that one wasn't bad. I actually read the question, got it right, hopefully. Let R be the region in the first quadrant, bounded below by the graph of blah, and above by the graph of the cube root of x. R is the base of a solid, so this is another known cross sections. Base of a solid, cross sections perpendicular to the x-axis, rectangles whose heights are 5 times their bases. If the base is in R, what is the volume of the solid? All right, let's start with, I guess a little graph maybe. So let's say we don't know what this looks like. I have a really good sense of what this looks like anyway, but doc 4, graph. Okay, so 1/3 x squared. And then cube root of x, I'm going to do x to the 1/3. And then let's box around this. Zoom box. Click, drag, click. Okay, and let's get an intersection point. Menu 8, 1, 4. Click, click. And while I'm here, I might as well store this. I'm going to store this as B. Store B. Okay, and let's see if we can do this. Why am I only on problem number 8 if I'm... did I forget to start a new problem? I did forget to start a new problem. That's really inconvenient. Well, best practices, what are you going to do about them? All right, so this is our image, our picture, right? So let's copy this down. We got this to this, 1.933. I don't really need that y value, so I'm not going to write it. I know that I'm perpendicular to the x-axis, so here I'm going to call this s of x. I tend to just call that s of x no matter what's happening, kind of like for segment, like the segment we're using. And we are told that, so s of x, top, takeaway, bottom, right? So x to the 1/3 minus 1/3 x squared. And we're told we got the base is in the x, y plane, right? The base is in R, so that's going to be s of x is the base, and then the height, so s of x is the base. The height is 5 times the base, right? So that's going to be 5 times s of x. All right, so not so bad. And then I know that I'm doing integral of a of x from start to stop. So that'll be the integral from 0 to blah, blah, blah of that, which is, let's work that out. So I'm going to put in doc 4, I'm put in a calculator page, and I'm going to say s of x is, so the problem is I don't know what my functions are. So let's do this. Var f1 is probably not what I want. f2 of x I want, and f3 of x I want. All right, so s of x is going to be f3 of x, right? Because I want the cube root, f3 of x minus f2 of x. All right, and then I want to do the integral, so that's shift plus from 0 to, I stored the value as b, although I'm going to check that anyway. And then if you type it in, 5, so you can get s of x from the var key. S of x squared with respect to x, press enter. Ooh, 3, that's disconcerting. Let's see what the decimals look like. Yeah, we're writing 3. Okay, so approximately 3. If you're not really sure if your b value is what you want, just type b and press enter. You can see that it is the value you want. All right, I'm going to start a new problem. I'm going to start 2 new problems. So doc 4.1, that's where I should have done problem number 9. Doc 4.1, this is where I'm going to do problem number 10. All right, particle moves along. What does it move along? Particle moves, let me get out of the way. Particle moves along a line so that its acceleration for t greater than or equal to 0 is given by a of t equals t plus 6 over radical t to the 4th plus 2. I feel like I use radical t to the 4th a lot in this problem set. If the particle's velocity at t equals 2 is 8, what is the velocity of the particle at t equals 5? Okay, so this feels a lot like, it feels exactly like the problem we already did. So we know at t equals 2, we're at 8. We're looking for our position at 5, or not our position, our velocity at 5. So at t equals 2, the velocity is 8, and we want the velocity at 5. So v of 5, we're just rearranging the fundamental theorem, v of 2 plus integral 2 to 5, a of t dt. And calculator problem. So a of t colon equals fraction template, t over 6, square root t to the 4th. I feel like I always rush through the last problem, just get it done like this. All right, so v of 2 is 8, so I'm doing 8 plus integral, which is shift plus from 2 to 5, because that's what we're doing, of a of t, press var, a of t, dt. I'm going to press enter, see what I get. I should probably do control enter just in case. So I get 10.6665, so 10.667, so approximately 10.667. All right, and that is it. So I don't know, I guess in this problem set, I demonstrated you should always read the problems. The calculator is a little bit slower. Make sure you really know what you're doing so that when you walk into the exam, you're not spending any time thinking like, oh, how do I do this? It's more about like reading the problem, thinking, I've done this before, and just going through the process. So I hope you found this helpful, and good luck.